Hi, my name's Wanda with GridX Partners, and I'm here to talk about utilities working with suppliers within the context of interoperability and standards. I think this is particularly important because there is a lot of interaction that has to occur between the two before standards even comes to be. And so, that back and forth process, the work that has to go on, the time that it takes is pretty intensive. And certainly, as regulators, you'll get involved to some extent in that exchange well before the standards are declared. And so understanding this process is important. It may not have been as important in the past because we were relatively static as an industry. Technology wasn't changing as much as it is now. But of course, as now we're bringing in more and more communications, digital capabilities, interoperability, and the exchange of systems, both on the operating side as well as the organizational side and the informational side. Understanding this exchange is important. So what happens first? First is innovation, followed by trials, pilots, early adopters, and then eventually you get a lot of people involved where there's a consensus around how things happen and standards begin to occur. And if you take a breath and you think about the electric utility industry, it's pretty amazing that we work 24/7 with hundreds of thousands of suppliers in the mix, and somehow it all miraculously works together. Whether it's poles and wires and computer systems and computational systems and generation, on it goes. But I mean, that's a lot of things that have to work together all the time, 24/7. Why? It's founded on standards. And the standards become about because of a stakeholder process that involves everybody, and eventually it gets to consensus and the standards are written. But between the time that standards evolve, these are the steps that occur. So on the innovation side, a lot of times suppliers will be working with the utility partners through users groups to get feedback on, challenges that they face in order to evolve solutions in order to address them. That often ends up being a differentiated offering that gives them, advantage in the marketplace. They might do prototyping work with a handful of folks that are really close to them to be able to understand if that functionality can come to the market. I've even seen suppliers provide equipment in a try-buy situation since they can't get, return on investment until there's costs and benefits and all of that is pretty well documented. So it's like, here, go try this equipment and see if it works. And if it works, you get to keep it and we'll build a business case around it. If not, we'll take it back. But this is just to overcome some of the barriers that are built into the process right now. Obviously, suppliers end up being very active in the stakeholder education process, maybe with regulators, maybe with communities, utilities, both internal and external folks alike. This is a hype curve that comes out of Gartner. You may have seen it. It's been around for a long time, but it's the Gartner Innovation Hype Curve. And a lot of times we get so excited about what technology can bring to bear, and the benefits get blown out, and it's just like, go, go, go. And then the reality is that they don't really deliver near to that extent. And once you lose the optimism and the faith, a lot of times in this industry, you don't get an opportunity to bring it back to bat, just because memories live so long and it's such a conservative environment. So utilities and suppliers work very hard to make sure that the expectations around the benefits and the delivery of functionality will work from the get-go. And that these demonstrations prove to be successful, and ultimately then it leads to a standards development process. I think, the ARRA, American Reinvestment Recovery Act, was, it had 131 projects. After the government money was matched, one for one, it ended up being $9 billion of investment in smart grid technologies over a whole host of different applications. One thing that it did do is that it brought folks together to learn about technology, think about operability, advance standards, and I think advance the adoption process. A lot of times in the electric utility industry, we're so conservative and we've done things relatively the same way for quite a while that this has actually facilitated, I think, an understanding in what can occur and deliverables on costs and benefits that can be relied upon in order to make advances much faster than we've been able to do historically. So it expedited the rate of technology adoption. So a few examples then of how utilities and suppliers might work together. One, I'm not going to use any particular names of either the utilities or the suppliers, but one case, a manufacturer is coming out with new standards on DERMS and ADMS, where the software can talk to a lot of distributed energy resources and, think about the functionality that's required. This is very much an emerging need in software. It lives in the real-time domain. And you can imagine the amount of exchange that has to occur between the utility, their real-time environment, how DER is performing in the system. So, this kind of situation is there where perhaps the standards aren't fully developed. Case in point, they aren't fully developed. They're in process and probably always will be in process. But it's a good, I think, example of how things evolve to a point that functionality can eventually be packaged in a product, or in this case, a software offering that's consistent enough that multiple utilities can benefit from. Cyber resistance is another example. Testing, working with a supplier to test all the way from the inverter through the communication systems, up into DERMS and the real-time environment, and then even back again, as you might ask for performance out of those DERs on things to do. So, thinking about going through multiple domains and the interoperability is there, and where, interfaces might occur, where there's soft spots for cyber attacks is another example of how suppliers and utilities are working together. I put a proprietary communication piece in on distribution automation. There's a lot of proprietary systems that are out there that have to map to either existing or new software. And a lot of times utilities get involved in that process. They might use DNP3, which is a standard for communications. It's readily accepted in North America, but a lot of times that's representing proprietary behavior behind the scenes, where the supplier themselves have to get involved in mapping that connection. Functionality testing. I think California has been a tremendous leader in Rule 21 and thinking about how to phase in standards for distributed energy resources. First, coming out of the gate with the idea of smart inverters, and then how to, think about communications to them and who communicates and who owns the data and how to manage that. And then ultimately how to, fully embrace the grid forming capabilities. This has been a large stakeholder process. It's taken a lot of time, but it's certainly evolved the community to a point that the IEEE 1547/2018 standard has been, modeled around some of that work. And it continues to evolve. There's still gaps in it, without a doubt. How to deal with aggregators and a middle layer is, it's evolving and will continue to evolve. Advanced analytics is, certainly another area where there's software, hosting capability, using meter data in a domain that wasn't necessarily real time, but that how do you weave that into forecasting so that it now becomes interesting and available on a maybe hour ahead or day ahead situation when you have a lot of DER. That kind of information becomes really important, thinking about how to balance the system and make sure it's stable. So my point here is that there's a lot of work that happens behind the scenes, even before standards are fully available. Your utilities are involved with this. It's a very important part of the step. Standards making ultimately comes around. It takes time. It takes a lot of involvement. I would also say that it's interesting to understand the perspective of suppliers in this process, because they've come up with proprietary systems, and there's a lot of differentiation and competitive advantage in proprietary systems. And now we're asking for systems to be open. So, that really takes a nudge from utilities and regulators alike to kind of change that from a proprietary to open system nature. Obviously, there's a lot of benefits in doing that, but it doesn't happen overnight. There's also advantages to, taking out the existing equipment and putting in new, because it results in incremental sales. But it may not be the best thing for the community at large, because it costs more to do so. So that evolutionary process needs to be thought about in the design, actually with the supplier. How do you make it modular? How do you think about incremental software that can be downloaded? How do you think about communications that can handle not only this application and also more down the road? A lot of this migratability piece is really woven closely into the design capability and needs to be contemplated very, very early in the process. So just to wrap up then, utilities and suppliers do work together hand in hand. A lot of work happens before standards are actually finalized. And it's a process that takes time, and we certainly need to support it for success.